All right, so a retroreflector is what I also call it a corner reflector. It's basically a bunch of these, which are just three mirrors that are at 90 degrees to one another. Okay? The whole idea is that when you shine a laser on it, no matter what angle you shine it at, it bounces back parallel. So hopefully you can see it the laser reflecting back on my hand. Let's see if I can get a good one there. Yeah, maybe not. I'm doing a bad job. There we go, on my hand there. Okay. All right, and it's always reflecting back parallel, but not exactly at where the laser's origin is. Now, it's hard to draw this three-dimensionally, but we're going to draw it two-dimensionally here. I'll show you what we're doing. So, if I have a corner reflector, which basically is just two mirrors, in two dimensions, just two mirrors at 90 degrees to one another, I would have light coming in, hitting one mirror. It's then going to bounce off, hit the other mirror, and then it's going to bounce off again. And I want to figure out how the angles of how it hits are related. Now remember, the law of reflection is is what governs this. And the law of reflection says the angle of incidence is the same as the angle of reflection, right? So, but they're always measured from the perpendicular. So if I was to draw a perpendicular line to that, that would be the angle of incidence. Or this would be how we measure the angle of incidence from. So this right here is the angle of incidence. And I'm going to make it 70 degrees. And so what it tells us is that this is also 70 degrees. Right? So then, what about, how does that relate to the angle of incidence and angle of reflection for this second mirror? And the answer is it's got to do with this triangle right here. So when I look at this triangle, we know the interior angles of a triangle add up to 180. And I know one of the angles is 90 degrees. So I can figure out one of the other angles, I can figure out the third. And so I'm looking right here at this corner right here. That angle is 20 degrees. And I know that because it and this angle have to add up to 90 because the perpendicular is always 90 degrees from the surface, right? So 20 degrees here, and then if this is 90, this angle right here becomes 70 degrees. And if that angle is 70 degrees, then this angle right here is 20 degrees, and that angle is 20 degrees. And if you do all this carefully, you'll realize that these two beams of light are parallel. You notice they're not actually in the same place, but they are parallel to one another. All right, so what if it wasn't a corner reflector? What if it wasn't 90 degrees? The process is still the same. So let's do this again, just with one where the mirrors are not at 90 degrees. So let's say they are now at, I don't know, 110 degrees. All right, what if my ray of light now is coming in at like 30 degrees. No, more than that. Sorry, 50 degrees. And it's going to bounce off, and it's going to bounce off. Okay. You'll notice these rays are pretty much not parallel. And I know I'm approximating it, but they're definitely not parallel here. So if this is 50 degrees, and I want to know what's that angle. So again, I start here. This is 50. That makes this 50. If this is 50, then that angle right here must be 40 degrees. If that's 40 degrees, then the 40 plus the 110 plus whatever this angle is have to add up to 180. So this then is 30 degrees, which makes this angle 60 degrees, which also by the law of reflection makes that angle 60 degrees. So if the first angle of incidence is 50, the second angle of reflection is going to be 60 degrees for a 110, for a reflector with or two mirrors with a 110 degree vertex between them. And that's how you do a double mirror problem.